show that the following are probability distribution functions. So the first one, p of x equals x squared plus 1 over 34, and that is for x values of 1, 2, 3 or 4. So I'll start with that. So to show this is a probability distribution function, I need to show that all of these, for all of the x's, 1, 2, 3 and 4, all the p of x's are between 0 and 1. You can't have a probability that's bigger than 1 or smaller than 0. So that's the first thing. And also I need to show that they add up to 1. So if the x's are all possible outcomes, so it can only be 1, 2, 3 or 4 for whatever this random variable is. It doesn't tell us, but in practice we would have some kind of context, and we'd have some random variable x that represents the number of something, the number of times you do this, the number of times this happens, that sort of thing. So we need to work out p of 1, p of 2, p of 3 and p of 4. So if we know those, it'll be quite useful. So p of 1, p of 2, and we need p of 3, and we need p of 4. Now this is a calculator question, so if you find yourself ever having to sort of do repetitive calculations, your best bet is just go into table mode. So if we just go into menu and table mode, number 7, if we just type the function in like that, so x squared plus 1 over 34 over 34, and if you go to the settings, it's already on the right settings actually, so we want to start on 1. So first x is 1 that we're evaluating on, this, the last x is 4, and we're going up in steps of 1, so that's fine. Go to the table and we get the y values, so the p of x values for the values 1, 2, 3 and 4. So the first one is 0.0588. P of 2 is 0.147. P of 3 is 0.2941. And P of 4 is 0.5. So firstly, they're all between 0 and 1, so that's fine. So all probabilities between 0 and 1, so that's the first thing we need to show, and then we need to add them up, and they should add up to 1. So if we just go into the main bit of the calculator and literally just add them up, so 0.0588 plus 0.147 plus 0.2941 plus 0.5, which does equal something extremely close to 1. It's only because of the rounding errors in the table mode that it doesn't equal 1. So what I'm going to do, you should show some working, so I'm going to write 0.0588 plus 0.147 plus 0.2941 plus 0.5 equals 1. So all probabilities sum to 1. So that is showing us p of x is a probability distribution function. I'm just going to write PDF. Right, part B, we've got p of x equals 3cx 0.6 to the power x 0.4 to the power 3 minus x, for x is 0, 1, 2, 3. Now this is actually a function that you'll be very, very familiar with before too long. This is the binomial probability distribution. We will cover that very soon, but right now I'm just going to do it exactly what the question asked me. So I need to show that when x equals 0, 1, 2 and 3, p of x is between 0 and 1. And I also need to show that all of those probabilities add up to 1. So for part B, p of 0, p of 1, p of 2, and P of 3. Now table mode really will save us quite a lot of time here actually. We go back into table mode. That's 7 for table. Get rid of that. And we want 3. Remember C, NCR is in option and prob. So 3 NCR X times 0.6 to the power X. 0.6 to the power X. That's not right. To the power X times 0.4 to the power of 3 minus X. Minus X, just like that. And we go to our settings, and here we want to start at 0 and end at 3, and we still want to go in steps of 1. So we go to table mode, and we've got some probabilities. So P of 0 is 0.064. P of 1 is 0.288. P of 2 is 0.432. And P of 3, 0.216. Again, all probabilities. Between 0 and 1, so that's fine. And then we're going to have to add these up. So 0.064 plus 0.288 plus 0.432 plus 0.216 equals, so hopefully it'll be 1, but we really should check. Menu 1, 0.064 plus 0.288 plus 0.432 plus 0.216. And that does sum to 1. So again, P of X is a probability distribution function.